Okay, did you see the movie here?
I did, yes, that was nice.
Okay.
Those were old pictures.
Yeah, do you remember that picture?
Yes, I do. That was fun.
Thank you. Yeah, thank you for participating this 2021 Open Source Festival run by Korean Ministry of Science and ICT and National IT Industry Promotion Agency. Can you start with saying hello to Korean developers?
Hi, hello all Korean developers and Linux users and developers. Welcome to the conference.
Okay, great. When you visited Korea before and been working together and met them, you have any episode or story or any developer that you particularly remember?
There's so many developers, right? None, I don't want to call any out specifically. I've known many Korean developers for many years. Some have left Korea to move to other countries. Taejun Ho, I've known for many years. But there's still many in your own country, and I've visited Korea many times. I've seen about half the country, and it's a wonderful place. I wish I could be there. I'm sorry I can't. Hopefully soon.
Right. We really hope in sometime in the future we will hopefully we can have another opportunity to meet in person and talk in person and get together directly.
I agree.
Okay, so let's get started with a series of questions to you. So you've started working on Linux for a long time. I've started to see your names on various subsystems on USB and etc. And now you're maintaining many parts of the kernel. Can you share how you started to work on Linux kernel, and also can you share what you are doing these days with regard to kernel?
Sure. So I used Linux at a job in the early 1990s. We were using SCO, Unix, and Linux on machines. So I messed around with it a little bit. I did a lot of embedded programming. And then at a job later on in the late 90s, I was doing programming for USB. I was involved in the USB specification process for tiny little bits of it. And I started having to test the device I made barcode scanners on all different operating systems. And Linux was just getting USB support at the time. It really didn't have it. So I started testing patches and seeing where I could help out. And there was like, oh, I can change this and help out, and it makes my devices work better. And I sent a patch in, and people liked it and took it and moved on. It was fun. And then I had some free time one weekend when my wife was away with my daughter, and I said, oh, let me write a driver. So I grabbed the Linux device driver book, and I had a device I wanted to have supported, and I wrote a driver, and I submitted it in. I sent it in. I was so proud of it. And like instantly, there was this response like, oh, this is wrong, this is wrong, this is wrong, this is wrong. And I was like, this is amazing. I love it. I want the critique. And what is this multi-processor machines? I've never heard of machines with two processors. What do you mean I have to do locking? It was great for me as somebody wanting to learn how to program better and do better. It was wonderful. So I made those changes, and I learned how to do different things, and submitted it. And I started writing more and more drivers for different devices, little USB to serial devices. And my company I was using didn't really use Linux much. And then I realized after a while that more people were using the drivers and the code that I wrote for free than anything I got paid for, because the company was successful, but it wasn't hugely popular in a way. And in the late 1990s, somebody offered me a job to do Linux full time. So I took that opportunity, and I haven't stopped since. So it's been a fun ride since then. Right now I'm at the Linux Foundation. I've been here for 6, 7, maybe 8 years now. It's me and Linus and Shua Khan are the only people working at the Linux Foundation that do kernel work. But I maintain and release the stable Linux kernels. Done that for about 17 years now, I think. And so that Linus does the main release every 3 months. I do a stable kernel release every couple of times a week, basically, depending on the release branch, but maybe once a week, maybe sometimes twice a week. And then that's what gets integrated into devices and distros, and they pull from those and do that. So I maintain the stable kernels, as well as I still maintain upstream the main USB subsystem. That's where I started out with, so I really like that, and I know that very well. Then there's other parts, drivers, serial, the serial part of the drivers, TTY layer, miscellaneous stuff, staging where new people can get involved in. There's code in the kernel that is purposely not cleaned up yet. So it's very easy to find basic parts of the kernel, like just fix coding style. And they learn how people can help out there and contribute very easily. That's a great place for new people to get involved. So I maintain that, and there's a few other parts of the kernel I maintain, and yeah, that's what I do. So I'm pretty much full-time doing this.
Excellent. So you've been working with many Linux kernel developers so far. I assume that over the course you learned how to work not only by yourself, but how to work with more people, and maybe you might have gone through some issues regarding communication and working with other people. So from your perspective, what is the most important way of communicating and working together with other developers?
The best way is, I like how we do it. We do it through email. And email is people make fun of us at times. It's an old way of doing things, but it's really, really good for when English is not your first native language. And I now live in Europe, in a country where I do not speak the native language. So I'm very appreciative of chances I have to slow down the language and being able to process it and then write it back out in the other language. Email is really good for expressing technical opinions and technical points and discussing things. So email is how the Linux kernel works. We send out email, you review things asynchronously. You don't have to be responding in chat at this moment. You don't have to have a meeting at this point in time. We're all around the world. We have different time zones. I'm in a different time zone than you are right now, which is a different time zone than the US right now. And it's very difficult to do that. So email is a very good way to do this type of thing. I think it's we always said that this is a great model of working. You can be remote. The Linux Foundation is remote, the company that's never had an office really. For a while there, we were just a fax machine over an auto repair shop. That was the only office for the Linux Foundation. And now it's just remote. And you can create something wonderful that works really well by working in this manner. Now, we're very lucky in that we're working with software, right? We don't need to have access to the hardware all the time. Sometimes you do, but I've worked remotely on projects where you just ship the hardware out to the software developers. They work on that remotely and you come back. I think with the lockdowns around the world for the past couple of years, it's proven that you can work remotely with the tools that we have, and it works out really well. So I think that's the future of good software engineering practices, that you can think of something offline, communicate it again, and work through good written communication. So you have to have good written communication skills, which is difficult, but it's a very common skill that everybody should learn.
Right. I completely agree with you. In particular, that this kind of email communication, the Linux kernel developers proved that it is possible and it is suitable, and you can work on some really big projects in a distributed manner, in a synchronous manner, with people distributed all different time zones. Can you think of any interesting or an interesting episode when you were working in this manner as a part of community and in a distributed way?
Oh, there's so many things. One is working in a distributed way. I have to go and work with lots of companies to figure out to help them get involved in the community, right? My goal is to help developers at companies that rely on Linux become part of our community, own the code that they rely on, because then the community grows. If your company relies on Linux, you're part of the community, you're going to help to make Linux succeed over time. So one of my favorite examples is I was visiting a company to try, and they were working on drivers, and their drivers were not submitted to the community. It really wasn't working out well. So I sat down with the engineers, I talked to them for many hours, and there was just really no communication. Nobody was really saying anything. And then the lunchtime break happened, and half the people left, the other half the people stayed, and somebody said, "Oh, we can't say anything because our CTO wrote the original driver." And we would be very upset and worried if actually somebody in the community made fun of that code or ripped that code out. And I thought that was very interesting because the CTO had brought me in to fix this problem. So I went to him and said, "Hey, this is what they're worried about. They're worried about your code." And he's like, "Oh, that code is horrible. It should be ripped out. I need to tell my engineers that it's okay to have this happen. I want this open communication model." And then once that CTO came back after lunch and told that to the managers and told that to the engineers, they're like, "Oh, okay, this is wonderful. Let's do this." And now that company is a very valued part of the community. They maintain their drivers in the kernel community. It works out very well. But that was just like a miscommunication between like the upper levels of the company and then the lower levels of the company, not wanting to worry about saving or disgracing somebody. That was a cultural issue. They thought that reviewing somebody's code in public and saying, "Oh, this is not working right," that's like a disgrace to the person, when really it is the learning experience. We're all trying to learn to make something better overall. And we point out flaws in code because we want to make the code better. So it's nothing about the person, it's an engineering. I mean, this is a review process. Same thing with writing, same thing with any type of art or work. You always have a critique and a review from other people, and that's how you learn and grow and get better. And like the upper management of this company realized that, it was just imparting that to the lower people and making that work better. So there's an example of a cultural disconnect in which we had to overcome just by figuring out. It wasn't a technical issue, it was a people issue. And people issues are very important because we are all people and we're all working together for the same goal. So we need to at least agree on that. As kernel developers, we have 4,000, 5,000 people a year. We don't all agree on anything, but we all do. Only thing we agree on is we want Linux to be better. Right? And we want to make this work for our use case, which is great because it turns out everybody usually has the same use case in a way. So we'll all contribute a little bit. We all contribute selfishly to make it work for us, and then it helps out everybody overall. And that's the whole goal. That's about the only thing we can agree on is that. So that's fun.
That's fascinating story. Yeah, I totally agree that being an open and honest and especially at a technical level, being able to be honest and open to anyone, and then go deep into the technical side is really important for producing a quality code, I believe. So that's great. So let's move on to the next question. So with that, you as a kernel developer, I assume you've been receiving lots and lots of patches from other developers. So in that, you as a reviewer, what do you see? What is the most important thing that you look for, or that you review, that is most important area you as a reviewer of a code?
Oh wow! So I think I'm the second most popular reviewer. I review the second most common code. David Miller in the networking reviews the most. There's some basic issues. So basic issue follows the proper coding style. Coding style is there not because our coding style is perfect or wonderful. It's there so due to your brain sees pattern and matches, and if you put the code in the same format all the time, the format goes away and you can see what the code means. And so the goal of that is you just have to have the proper coding style. We have tools that check for it, so before you send it out, pass it through our tool, and then everything will work properly. So easy thing. So if the coding style is wrong, that it screams out to me, and it's instantly, okay, I have a little bot that says, respond to the email saying, go fix this. After that, then there's like follow the proper format, making sure you don't have to comment your code really, really well. You just have to make it easy to understand and easy to read. Famously, when the KVM code first got merged into the Linux kernel, It was submitted by Avi, and Linus said, "Oh, I don't really understand how any of this works, but it looks wonderful, so let's take it." Because the code quality and the code, the way the structure was, and it was just obvious that you could follow it if you had to, you could understand it. It worked out properly. So you don't want to say it's like the smell of the code, but it's if you look at common core kernel code, it's very easy to understand. We're not doing complex things. The kernel is not a very complex or intricate thing for the most part. There's some parts of it, some parts of networking stack, some parts of scheduling, but most of it is we write code for people first, the compiler second. So we want to make sure it's easy to read. We don't try and do tricky things, because the compiler and the CPUs can easily figure this out and optimize it away. So make it easy to understand and read and follow, because you're going to have to fix these bugs in that code in 20 years when you have to go back and read it. You want other people to find and fix your problems. I want to write code so that you will fix my bugs, because we all write bugs and we all have problems. So make sure it's easy to understand, it's obvious. And then also another good thing is write a good explanation for what the change is you're doing. We have, it's often harder to write the changelog comment than it is to write the code in the first place. And you have to go back and think about it. You need to explain, don't just say what you did, because you should be able to read the code to do that, but why you're doing what you're doing. So that when we go back in time and look at this commit, oh, I see what it does, but why? What was the reasoning behind that was changed to this way? So explain it in simple language, nothing complex. Just make it obvious. You need to make it so that it would be foolish for me not to accept your change. So make it obvious. And another thing is, along that way, you have to break down your changes into small individual pieces. You can't just say, here's a big, massive change. You have to do what your math professor used to say, is show your work. You have to say this step, and then this step, and then this step, and then this step. It's more work on an engineering point of view to have to break down your changes into small logical pieces, but it works better. Other people can review it easier. When you submit a 10-patch series, because you want to do this complex thing, as a reviewer, I can say, oh, I don't agree with parts of this, but your first 5 changes, wonderful. I'll take those now. And then that takes that off your plate, and then you can continue and work and revise your next couple of changes. And that's an evolutionary process. So that lets other people comment and change and look at how the individual steps of your proof are there and what that can be done better. And we have huge examples in the kernel of work over time that has been made better by other people because of this review. When we did the driver model in the kernel in the early 2000s, we're like, oh, Pat Moschel and I, here, let's do this crazy stuff on how we can unify all devices. And other people said, oh, as you're breaking that down, well, here, you can break those steps down to even the smaller pieces so that it works in other parts of the kernel. And you can take those pieces out and do other things, and you can refactor it. So by the basics of reviewing it and breaking things down into smaller pieces, it's easier for other people to help you out and do work. And it is more engineering effort in the short term, but in the long term, the result is something better than you could ever do. So break your changes down into small pieces, explain them well, and make it such that it would be foolish for me not to take these changes, right? Don't give me a reason not to. That's a good thing to do.
I think that's a really, really nice explanation of how you can be a more collaborative developer when you work with other people. You know, let other people to understand why you are working on this problem, and then helping other people to understand your code easier, and then also ultimately making it more compliant to the coding style within your team. I think that's a really good summary of how you can be a more collaborative developer in any team.
Yeah, and that works for any engineering process. Within your own company, you want other people to review your stuff and critique it and see how it's going, and because you all are working towards the same goal, right? So these are just good, solid engineering practices that we've brought to the kernel, to the open source community over time. Everybody should be doing these, no matter what you're working on.
That's awesome. That's really awesome. Last question. you've been a long time developer, and so you as any advice for young developers to become a better developer?
Sure. Number one, contribute to the Linux kernel and you can get a job. There's so many jobs right now. We have a lack of people to solve or to fit all the jobs we have. That being said, there's really easy ways to get involved in the Linux kernel. Like I mentioned earlier, there's the staging part of the kernel that has basic coding style issues. Fix those up. You learn how to fix your email client. You learn how to write the proper change log. You learn how to submit the stuff. And after you learn that, then you can go off and tackle other parts of the kernel and solve problems that you want to solve there. But with the work that's even just in the staging tree, people get jobs. There's maintainers of major subsystems in the kernel today that started off their life just fixing up white space issues and drivers in the staging tree. So if you're interested in working on this, contribute that way. You can, especially if you're still in university or in school, you have the time to work on open source projects. There's wonderful intern opportunities. The Linux Foundation, we run an intern project 3 times a year for the kernel. I have a number of interns that work on this type of stuff. PCI maintainer, the K self-test subsystems. There's lots of intern opportunities that you get paid to do this work for 6 months. We're good at Outreachy, Google Summer of Code offer these types of things. Get involved in some type of open source work. The best reason why is it is wonderful to look on a resume. So if I'm hiring somebody, I can say, oh, look, not only that these are your school projects, which I don't really know how you did, or your grades, okay, I understand how you do that. But when I see you working on an open source project, I can see how you interact and work with other people. And that's just as important to be a good developer because you have to work with other people. You have to be able to communicate with other people. You have to be able to respond to criticism, provide criticism and critique. Those are all very important real world skills that you learn doing open source development that can translate to working at any company. You don't have to always get a job doing open source development. I would love it if you do, but it's a great opportunity. When I worked at companies that were hiring people, if I saw a resume that showed you had open source work, I'd go look it up. Oh, wonderful! Look, they can talk to other people. They can do this type of stuff. That's okay. To the top of the list they go. Right? It's an easy way to get involved. And it's open and it's available to anybody. All you need is an internet connection. We have people working that have joined, that have become interns for Linux Foundation, working in all countries all around the world, Egypt, Asia, all sorts of different countries. And then they get jobs based on that afterward. There's tons and tons of opportunities. So please get involved. We have lots of work to do. We have lots of things, lots of problems we want to solve. There's loads of companies that want to help pay for you to solve those problems for them. So help get involved. I know there's loads of open positions. Just in Korea, there's a number of companies just wanting to hire people to help work on this stuff. From your government to the companies, I've worked with a number of companies in Korea. Everybody wants to hire people with the skills to do this type of stuff. It's a wonderful time to be a programmer. We should take advantage of this stuff, and the opportunities are there for you. Okay,
wow, yeah, that's a really great remark and summary as well. Greg, thanks for taking your time to join this interview. So as you can see, we've been running this open source conference every year. And if this, hopefully next year, if this is hosted in an offline, in-person manner, then would you be coming in person here as well?
I would love to if I'm able to. Yes, I don't know what my schedule is at the time. But yes, the way my country looks right now, things are locking down again, so it won't be anytime soon. But a year from now, I would hope that we can travel again and do that. But I love visiting Korea. It's a wonderful place.
Thank you.
I would love to visit again.
Thank you. Yeah, we really want to get together in person again, and let's go to the fish market again as well.
The fish market was wonderful. I love that. That was the best fish I've had in so long. Yeah, that was wonderful.
Thank you. Thanks for joining, and
Thank you.
yeah, have a great time. Thank you.
You too.